Myself, R.D. Umrikar, lecturer in electronics, Government Polytechnic, Ahmednagar. Today I will tell you some important information about capacitor. Capacitance is a fundamental concept in electronics and physics describing the ability of a component known as a capacitor to store electrical energy in an electric field. It is a measure of system's ability to store and release electrical charge. Capacitance is denoted by the symbol C and is measured in farads. 1 farad is defined as 1 coulomb per unit. So as we know, the capacitor is very important electrical device. It is used for storing the energy and it has got different applications that we will discuss afterwards. So the capacitor is basically two parallel plates separated by dielectric material in between them. The dielectric material can be air, mica, paper, glass. So any uh, insulating material that will be used as dielectric media in between these two. A capacitor typically consists of two conductive plates separated by a dielectric material. So the dielectric insulates the plates and determines the capacitance based on its electrical properties. So formula for capacitance is C equal to Q by V, where Q is the charge developed and V is the voltage applied. So how much charge or energy which is stored in capacitor, that is measured by Q, whereas the V represents the voltage applied. So ratio of charge stored to the voltage applied uh, defines the capacitor. The capacitance is directly proportional to the charge stored on the plates and inversely proportional to the voltage across the capacitor. In other words, a higher voltage results in higher charge for a given capacitance. So when a voltage is applied across a capacitor, it stores electrical energy in its electric field. The energy stored in capacitor is given by the formula 1 by 2 CV square. So the unit of capacitance is farad. Capacitance is a measure of a capacitor's ability to store electrical charge. It represents the ratio of the stored charge to the voltage across the capacitor. Voltage rating. This specification indicates the maximum voltage that can be applied across the capacitor without risk of breakdown or damage. So if you exceed the voltage rating, means every capacitor has got its voltage rating, that is the maximum voltage which we can apply across the capacitor. If we exceed that voltage rating, the capacitor will be damaged. Tolerance is expressed as a percentage and represents the allowable deviation from the specified capacitance value. For example, a capacitor with a 10% tolerance and a marker capacitor of 100 microfarad called have an actual capacitance between 90 microfarad to 110 microfarad. It means the tolerance means the manufacturer specifies the how much the capacitance value can deviate from its manufacturing value. That is the if the 10% tolerance is told for a 100 microfarad capacitor, then its value can uh, change from 90 microfarad to 100 microfarad. That is the meaning of 10% tolerance. Dielectric material is the insulating media which is used in between the two plates. So different dielectric materials have varying properties, as I have told earlier. Air, mica, then glass, paper. These are the different types of dielectric materials. Then the temperature coefficient. So the temperature coefficient indicates the how capacitor responds to the change in the temperature. How the capacitance value changes uh, as the temperature changes. Minimum operating temperature. That is the capacitors have a specified maximum temperature. Maximum operating temperature. That is the maximum operating temperature specifies how much maximum temperature the capacitors can tolerate. If you try to operate the capacitors above that maximum operating temperature, it will be damaged. Then package type. Different types of packaging techniques are used for uh, manufacturing of capacitors. So different packages are radial, axial, surface mount and others. Then polarity. So there are two types of capacitors, polarizer and non-polarizer capacitor. Polarizer capacitors are having fixed positive and negative terminals. For example, electrolytic capacitor. And some capacitors, they are non-polarized, means they will be not having fixed positive negative terminals. As in resistor, you can use any terminal as positive and other terminal can negative. For example, ceramic capacitor. Then different types of capacitors are ceramic capacitors, film capacitor, power film capacitor, electrolytic capacitor, paper capacitors. So these capacitors uh, are basically considered as the two types of capacitors, fixed capacitors and variable capacitors, and they can be also classified according to the dielectric media which is used in between the two parallel plates. Ceramic capacitor, as I have told, it is non-polarizer type. You can use any terminal as positive or negative. So ceramic material is used. A ceramic capacitor is considered to be one of the most commonly used capacitors. The material used in this capacitor type is dielectric. So applications, they are used in PCB for high density applications, DC motors. So in a transmitter and receiver for resonant circuit. Then film capacitors. Film capacitors are also known as polymer film, plastic film or film dielectric. The advantage of film capacitor is that they are inexpensive and come with limitless shelf life. The film capacitor uses a thin dielectric material, with the other type of capacitor is metallized. Then power film capacitor. Construction techniques and materials that are used in power film capacitor are similar to that of ordinary film capacitors. As I have told, electrolytic capacitors are polarizer capacitors. They have fixed positive and negative terminals. So as it is told, the positive terminal which is shown, that should be connected to the positive terminal. So they are having fixed positive and negative terminals. So these are type polarizer type capacitors. Then applications of electrolytic capacitors, they are used when there is a requirement of large capacitors. They are used in filtering devices. They are used in audio amplifiers. They are used in smoothing the input and output signals in DC signal. Then paper capacitor is also known as fixed capacitor, in which paper is used as dielectric material. The amount of electric charge stored by the paper capacitor is fixed. Applications, they are used for filtering, coupling and decoupling systems. They are also used for blocking the DC signals so that AC signals are passed through. So they are used as sensors such as humidity sensors, fuel level sensors. These capacitors are used in audio systems of cars as they provide extra power to the amplifier.